Hi everyone. This will be for vPc part two. So I talked about vPc peer keep alive and everything. Just to recap, so vPc peer keep alive is just a link to monitor link. So this is vPc peer keep alive, and um, so it monitors the link between the VPC peer devices every second. The heartbeat is 96 byte in length, and it can be used like not just with the direct keep alive, but it can be used with port UDP as well, which is 3200. If the peer link fails, connectivity is checked across the VPC peer link using peer keep alive. A holdout timer starts as soon as the VPC peer is deemed unavailable. So if this is not connected, this will start its timer, and during the holdout time period, the secondary VPC device ignores any VPC peer keep alive message to ensure that the network can converge before action is taken against VPC interfaces. So a secondary, any of the secondary ones, it will stop taking any VPC keep pair alive messages, and after the holdout time period expires, the timeout timer begins. Like that is, let's say default is 3 seconds. So if a peer keep alive message is not received during this interval, the VPC peer on the secondary switch are shut down. So that's how the peer keep alive works. Yeah. Now, so we know that VPC peer links are um, these links are VPC peer links, and it is used to synchronize states and forward data between VPC peers. It is very obvious, and it must be like the speed should be at least 10 Gbps or higher on an Ethernet port, and it is typically configured on a port channel to ensure that sufficient bandwidth for traffic between the VPC peers. So in case of like modular Nexus switches, it is recommended to spread across different line cards and modules. There is another concept known as VPC consistency checker. So Nexus OS contains a specific process called the consistency checker to ensure that the settings are compatible and to prevent unpredictable packet loss. So based on consistency checker, it will check if it's compatible, the data, and sorry, the settings between the two VPC peers, and like it prevents packet loss. Okay, and there are two types of VPC checker. First is type 1, the VPC instance and the member ports. So these gray are the member ports. So these member ports as well as its instances um, yeah, so the VPC instance and the member ports on the operational secondary switch. Let's say this is the operational secondary switch. So it enters into a suspended state and stop forwarding network traffic. The operational like primary network switch will still forward like network traffic. So this happens if the consistency trigger is not working and it's inconsistent. The type 2 error indicates that the potential for undesired forward behavior, such as having a VLAN interface on one node and not on another. So this is type 2. Type 1 is just to if there is some any problems, then secondary will like operational secondary will stop forwarding and it will become unoperational, and the operational primary is still switch still forwards network traffic. So that's how the consistency checker works. And So there is another one which is VPC peer gateway. Uh, so it allows a VPC device to route packets that are addressed to the router MAC address of the VPC. So here I am not included that, but if you can say is that it's connected to another router which is to the layer 3 device, and it allows the VPC device to route packets, like to route these packets to uh, the router MAC address of the VPC peer. It is used to overcome scenarios with misconfiguration or issues arising due to load balancer or like network attached storage, which we will talk about later, which is trying to optimize the packet forwarding. Packets that are forwarded by the peer gateway feature have their time to live decremented. Packets carrying a TTL of 1 thus might get dropped in transit because of TTL expiration. So this is what the VPC peer gateway is. And so after talking about the VPC peer gateway, we can say that there is layer 3 routing over VPC. So in this one, there is two switches that we already talked about. There is its domain. This is VPC domain. Now these are connected via a port channel. Now these two are connected to a router, and this is also a trunk port. So now the starting nexus, which starts from the 7, provides the capability for the SVIs, which is switch virtual interfaces, to form a routing protocol agency using a VPC interface with a router, like this. Now layer 3 routing over VPC is configured under the VPC domain with the command, we use the command layer 3 peer router. The peer gateway is enabled when using this feature. That is pretty much it. Now in data center, we generally use two types of design to VPC for VPC. So in data center, one is single sided design VPC. So how this works is that we have nexus, let's say 7 switch 1 and then nexus 7 switch 2, both are connected VPC domain. Now let's say there is another switch 1, there is a server, and there is a load balancer. Now let's say all are connected to each other, something like so. Now in this one, this is known as single-sided design. So the problem with this is that it is very limited in scale. It is for smaller L2 device domains. So only layer 2 works here. So there is 8 port on each VPC peer, and it's like all switch 1 server load balancers supports port channel with LACP or on feature. Now this is what L2 domain is. Now for a bigger or like more like larger in scale, for bigger L2 domains, we use generally double sided. So there is nexus 7, then there is nexus 5 K1, there is nexus 5 K2. This is aggregation layer. This is access layer. Now this is connected to the same way. Switch one, server, and then load balancer. So here we have the option to connect more and more devices, as there are 4 switches which can be connected to each other, and so that's how it's more like less limited in scale, and it can incorporate larger L2 domain. Now how do we configure the VPC? So configuration. Since if you want to test it out, you have to do it on GNS3, but I'll just be going through the very high level configuration of how it is done on the VPC. So we go inside ConFT, then we enable feature LSCP for LSCP if you want to do that, and then we do feature VPC, then we give a domain and its ID, let's say 12. Then what we do is we do peer keep alive, that is the one of the components in VPC. We have to specify a destination IP address, let's say it's 10.1.2.2, and the source from where you are doing the interface and everything, 10.1.2.1, then VRF default. And then we can check whether the VPC has been configured or not using CDP neighbors. Then we can if we are configuring VPC peer link, what we do is we check the Ethernet ports, we do channel group, let's say 10, mode active, then we do no shut, then Ethernet port 10, port channel 10. Then we do the same thing what we used to do is for VLAN switch port mode trunk VLAN, and this is the VLAN and STP part, switch port trunk allowed VLANs, let's say 10 and 20. So this is how VPC peer link is configured, and we can check if everything is working fine using show VPC, show port channel summary, then show VPC consistency parameters, VPC and its number. So this is how we do it. Now this is probably what VPC is altogether, and that's pretty much. Thank you.